In the standard theoretical framework for a traversable wormhole, we construct two connected mouths. Mouth A remains anchored here on Earth. Mouth B is placed aboard a spacecraft, which immediately accelerates to a relativistic velocity, embarking on a long journey away from the solar system. This split screen shows the classical time dilation effect resulting from that journey. Because of extreme speeds, the proper time, the physical time registered by an internal clock, will wildly diverge. The returning ship records 59 days of elapsed proper time, while Earth records 1,200 years. The conventional mathematical accounting of general relativity yields a specific conclusion. Because of the severe time dilation along the ship's trajectory, the two wormhole mouths are now completely desynchronized in time. This leads directly to the famous paradox assumption published by physicists Michael Morris, Kip Thorne, and Ove Yurtsever in 1988. They concluded that traversing the spatial shortcut from the ship to Earth will deposit the traveler 1,200 years in Earth's past. We need to examine the precise logic of this assumption. Why does extreme local time dilation, combined with a spatial shortcut, universally guarantee backward temporal transit? The TCGS-SEQUENTION framework approaches this problem through a strict geometric ontology. It argues that the math supporting wormhole time machines relies on a singular foundational flaw. The framework identifies this flaw as the Minkowski trap, named for the mathematical space standard relativity relies on. The Minkowski trap is the categorical error of treating time as an ontic traversable dimension, a physical direction a traveler can move through. By treating time as a traversable dimension, the standard general relativity narrative mistakes map-level bookkeeping for a physical, navigable territory. Specifically, it reifies a mathematical indexing label called the foliation gauge into an actual flowing river of time. As the schematic shows, the TCGS framework formally rejects the backward timeline loop. A wormhole can provide an effective superluminal spatial shortcut across vast distances, but ontic temporal loops are geometrically impossible. To understand why the math forbids time travel, we must rebuild the architecture of reality from the ground up, entirely removing the concept of a flowing physical time dimension. Axiom 1 defines reality as a static four-dimensional counterspace containing all events simultaneously. Our 3D universe is merely a geometric projection of this block, an illuminated intersection called the shadow universe. The lambda symbol indexes this scanning plane as a projection artifact, not physical time. Within the bulk of the counterspace block, the concepts of past, present, and future disappear. These are sequential rendering artifacts experienced by an observer embedded within the advancing shadow projection. Because time is exactly this scanner index, there is no physical dimension through which a traveler can turn around and drive backward. The scanner simply continues to index the geometry. Here, a wormhole is modeled as a static handle, embedded permanently within the four-dimensional counterspace. As the scanning plane moves, it slices across this handle. The wormhole's two mouths are simply the localized points where the scanner intersects the tube's boundaries. Operational time is an internal functional integrating the sector lapse over lambda. Ship and Earth start at lambda 0 and reunite at lambda 2. Between these bounds, their mathematical integrals severely diverge, locking in 59 days for the ship and 1,200 years for Earth. The standard narrative contains a clear geometric contradiction here. Both the ship and Earth physically exist on the exact same lambda 2 scanner slice at the moment of reunion. Therefore, the 59-day versus 1,200-year difference cannot represent a temporal displacement. The illusion of time travel arises from conflating the vast spatial distance of the ship's journey with inevitable experiential time dilation. Distance does not compress the experiential rate. If a traveler navigates a completely smooth spatial corridor to a destination 1,200 light-years away, they will experience exactly 1,200 years of aging. Foliation roughness is a measure of local irregularity in the projection structure, dictated strictly by the gravity regime. It is the true controller of experiential rate. The ship's extreme high-gravity corridor dramatically increased this geometric roughness, dynamically suppressing its sector lapse functional compared to Earth. Biological aging, atomic decay, and cognitive moments are proportionally compressed by this localized roughness. The scanner is simply resolving the experiential content of the ship at a drastically lower density per sweep. A short spatial trip in a high-roughness gravity regime causes massive clock compression. A massive spatial trip in a low-roughness regime causes zero clock compression throughout the entire journey, regardless of the severe gravitational roughness encountered by the ship. Neither sector ever disconnects from the shared foliation leaf structure. The resulting clock disparity is strictly a rate asymmetry in localized experiential reporting. It has absolutely nothing to do with ontic temporal displacement. Here we see the precise moment of traversal. The ship and Earth are reunited, and both mouths are firmly anchored at foliation leaf lambda-2. Mathematically, a traversable portal must operate as a slice local identification map, known as the slice matching coherence condition. A stable portal requires both mouths to be compatible with the exact same foliation gauge. Entry at leaf lambda-2 strictly dictates exit at leaf lambda-2. The core demand of the time machine paradox is that a portal can bridge two entirely different moments. It requires a cross-leaf identification, forcing a jump from the lambda-2 plane all the way back to the lambda-0 plane. This Minkowski diagram illustrates the admissibility criterion. Distinct foliation leaves are isolated three-dimensional submanifolds, mathematically disconnected by any admissible geometric immersion. Forcing a cross-leaf identification violates projection geometry. The portal fails to stabilize as a coherent physical event in the shadow universe. Stepping through the portal deposits the traveler on Earth exactly when they left, 1,200 years in Earth's future. Closed time-like curves are mathematically impossible. Stephen Hawking famously proposed the chronology protection conjecture, positing that the laws of physics must prevent the creation of time machines. This conjecture assumes temporal loops are geometrically valid structures that must be actively destroyed by violent physical mechanisms, like quantum backreaction, to protect the timeline. Under TCGS-SEQUENTION, the universe requires no physical protection mechanism. The geometric threat of time travel never existed in the first place. The framework draws a hard line between cross-leaf transit, which is categorically forbidden, and cross-leaf coupling. Cross-leaf coupling is governed by the KS kernel, a mathematical function that connects information across different foliation leaves. This coupling allows for non-local constraints that mediate retrocausal-looking correlations. But pure information feedback across the projection geometry is not physical temporal transit. A wormhole is an effective superluminal spatial shortcut through the four-dimensional counterspace. Nothing more. The 59-day time machine remains a map-level gauge anomaly. Within the TCGS framework, the cartographic geometry of reality dissolves the mechanism for temporal transit.